Hello, my name is Steve Bowler, and welcome to the Juniper Intermediate System to Intermediate System IS-IS Lab number 4. In this lab, we're going to take a closer look at the metric, wide metrics, and reference bandwidth within IS-IS. So let me just go ahead and take a minute to explain our current network topology. We have 4 routers. They're all logical systems, and they are connected via logical tunnel interfaces. If you're not familiar with logical systems or tunnels, I would watch our Juniper Series 1. We have 2 videos that are logical systems, labs number 1 and 2, that go over everything you need to know. We have that all logical tunnels equal LT-120.XX. What this means, for example, is the connection between router 3 and 4. We have the abbreviation LT.34. That is actually LT-120.34. So we shortened it just so we don't clog up our network diagram with too much detail. The networks are between router 1 and router 2, we have the 12 network. Between router 2 and router 4, the 24 network. Between router 3 and router 4, the 34 network. And between router 1 and router 3, the 13 network. All of the routers have loopbacks. R1's loopback is 1.1.1.1/32. Router 2 is 2.2.2.2/32. And so on for router 3 and 4. So all of the routers also have the net address of 49.0.0.0x0.0x00.x00x.00. And if you're not familiar with IS-IS, every router has to have a net address in order for IS-IS to work properly. So these net addresses, there's one per router. So for router 1, you would just replace the X with a 1 for all of the 4X places. Same thing with router 2, 3, and 4. So we're going to go through and initially configure IS-IS. So we'll show you where that's done. If you're not familiar with IS-IS, we do have videos on Juniper Series 2 that go over the basics of IS-IS. That's that's Intermediate System to Intermediate System Lab number 1, where we explain the basics. We go over the net address in detail and some of the more specifics. So let us also let you know that for the interface IP addresses, router 1 is using the .1 in the 4th place, or the 4th octet. Router 2 is using the .2. Router 3 is .3, and router 4 is .4 for all the interfaces. So what we're going to do, we're going to start this lab with the same initial configuration from our OSPF metric and reference bandwidth lab. That is OSPF lab number 10. And the only difference between that initial configuration and this initial configuration is that we are using the encapsulation in which we're using in this video is frame relay. So there's no difference in Ethernet or frame relay. We just wanted to show that it doesn't matter which one you choose, the results will still be the same. So if you want, you can use Ethernet instead. The other difference is that we have loopbacks assigned on all routers, not just R1 and R4, like we told you before. So let's go ahead and add our initial IS-IS configuration. Okay, so sorry about that. Just had to make sure we had the initial configuration dropped into the router. So we just did that. We're going to go ahead and commit and quit. It looks like we have a problem with our logical system on R2. Let's go ahead and see if we can figure that out. So we'll do show logical system, and on router 2 we do have loopback 0.1. That's not right. So let's go ahead and change that. We'll do set logical systems R2 loopback 0.2 family interfaces loopback 0.2 family inet address 2.2.2.2/32. Then we'll go ahead and do a delete logical systems R2 interfaces loopback 0.1. It looks like router 3 we have the same thing. Let me go ahead and just get rid of that. Delete logical systems R3 interfaces loopback 0.1. Then we'll create the loopback on R3, which is family inet address all threes /32. Let's take a look at logical system R4. Looks like that one's correct. So let's go ahead and commit and quit, and we'll go ahead and log into well, actually, what I will do before nope, let's go ahead and do that. Let's do set CLI logical system R1, and we'll do go into edit mode, and we'll do set interfaces loopback 0.1 family ISO. This is for IS-IS. And then we'll put in our address of 49.0001.0.100.1001.00. Then we'll add our interfaces to run IS-IS. So we'll do set interfaces loopback, LT120.12 family ISO. And we'll run IS-IS on 13. Then we'll go into the protocol and add the interface. So there's multiple steps. Like I said, if you're not familiar with what I'm doing right now, go back and watch the Juniper IS-IS Lab number 1, in which I go over all these commands in detail and exactly what they do. Okay, so router 1 is complete. Let's do the same thing on router 2. Set CLI logical system R2. Let's see how fast we can do this. So 49.00.01, that is our area. So 0020.0200. Alright, so that's our net address. Like I said, there's multiple fields, like the area and other identifiers. We're not going to go into those. If you want to understand all those, watch our Juniper Series 2 video we have, IS-IS Lab number 1. So now what we're doing is we're on router 2. We're starting the IS-IS process on our interfaces, our logical tunnel interfaces. Alright, router 2 done. Let's move on to router 3. Set interfaces loopback 0.3 family ISO address 49.0001 0030 0300 3003.00. Family ISO. Set protocols IS-IS interface LT120.31 34 and our loopback 0.3. Alright, that's it. So the basic IS-IS configuration is done on router 3. Let's move on to router 4. Set CLI logical system R4. We'll go into edit mode, or I'm sorry, configuration mode. Set interfaces loopback 0.4 family ISO address 49.0001 0040 0400.40040. Turning on the ISO family under our interfaces, connecting to router 2 and router 3 from router 4's perspective. So set protocols IS-IS interface LT120.42 43 and our loopback, which is 0.4. Okay, so that's it. What we just did, we set up our basic IS-IS configuration on all 4 routers. And for simplicity, we're going to leave the IS-IS routers as their default type, which is an L1, L2. For more details on L1 and L2, those are in IS-IS Lab number 1 and 2 on Juniper Series 2. So let's look at R1 for the IS-IS metrics, the default metrics. So let's jump right into this lab where we're going to teach you the metric, wide metrics, and reference bandwidth within IS-IS. We're going to show you the default behavior. Then we're going to look at tweaking the metrics along with the reference bandwidth and show you some of the gotchas that IS-IS has and ways to prevent those types of gotchas from happening in your real world scenario or on a Juniper certification exam. So on router 1 we'll do show IS-IS interface. What we should see is we have our loopback and our 2 logical tunnel interfaces going to router 2 and router 3. So if we do a show route protocol IS-IS, we can see that we are learning the 2, 3, and 4 networks. Those are all the loopbacks from the other routers, which is exactly what we want. Let's go ahead on R1 and before we move on to that, just wanted to show you the metric that's showing up for our logical tunnel interfaces right now is 10. So we'll get to that and how IS-IS calculates this in 1 minute. But the first thing we wanted to tell you is that this metric of 10 is not calculated based on any formula. By default within IS-IS, all interfaces are going to show up with the metric value of 10. But before we jump into all of that good stuff within the metrics of IS-IS, let me just want to do some simple tests for reachability. So we're going to trace to router 4's loopback. We'll source it from our own loopback on router 1. And you can see that we have reachability. It appears through router 2. So from router 1's point of view, we're going through router 2 to reach router 4. No problem. Looks like we have reachability. On R4, let's take a look. If we do a show IS-IS interface, see that we have it running on our loopback and on our logical tunnels, going to router 2 and 3. On R4, if I do a show route protocol IS-IS, you see that we are receiving all of the loopbacks from the other routers along with their connected networks, the 12 and 13 network. And we'll do a simple trace to the 1 network, and we'll source it from our 4 network. You can see that this trace is actually taking a different path. It's going to router 3 to get to router 1's loopback. So from our show IS-IS interface, we are seeing a default metric of 10 given to our IS-IS interfaces. We saw that on router 1, and we also see that on router 4. If we did this show IS-IS interface on router 2 and 3, we would see the exact same thing. We are also seeing for our loopbacks a metric of 0. And if we go back to router 1, if in our routing table, to get to the 4 network, we're seeing a metric value of 20, which makes sense because there is a metric of 10, if we go back to our network diagram, between R1 and R2, and then there's a metric of 10 also between 2 and 4. So all these links by default are carrying a metric value of 10. That's why we are seeing, doesn't matter if we go to router 4, we'll see the same thing for the 1 network. It's coming up with a metric of 20. That is because there's 2 links that carry a metric of 10 each, which gives us a metric value of 20. So having a default metric of 10 for each interface is not optimal. So let's consider the following situation. What we're going to do is we're going to make R1 to R2, we're going to make that link 1 gig. We're going to make the link between R2 and R4 1 gig. Then we're going to make the link from R1 to R3 10 gig and R3 to R4 10 gig. So the preferred path we should see is all traffic going R1, R3 to R4 because it has a higher bandwidth, a 10 to 1 ratio. So 10 gig is the lower link path, 1 gig is going to be the upper link path between router 2, through router 2. So let's go ahead and do that real quick. On R1 we'll do set interfaces LT120.12 bandwidth 1G, and that's for 1 gig. And then the link between router 1 and router 3 is going to be 10 gig. Go back to router, let's go to router 2. We'll do set interfaces LT120.21. That's the connection back to router 1. We'll give that the bandwidth of 1 gig. And between router 2 and router 4, which is the .24, we're going to give bandwidth of 1 gig as well. So that's the slower link, that's the upper link. Let's go to router 3. All the interfaces on router 3 are going to have 10 gig. So we'll do set interfaces LT120.31. Bandwidth is going to be 10 gig. And to router 4, which is the 34 link, it's going to be 10 gig as well. And on R4, the last router, we'll do set interfaces LT120.43. That's linked to router 3. Bandwidth is going to be 10 gig. And the link to router 2 is going to be 1 gig. So now what we're going to do, we're going to go back to router 1 and 4, and we're going to look at the interfaces. We'll do a show IS-IS interface. Metric is still the same for both links. If I do a show route protocol IS-IS on R1, I'm sorry, show route protocol, not OSPF, IS-IS. See, our metric values are the same. 10s and 20s. That's what we had before. To the 4 network was 20. Let's go to router 4. We do a show IS-IS interface. The metrics are exactly the same. Do a show route protocol IS-IS. And the metric for the 1 network is the same at 20. So even with the difference in the interface speeds, the metric of 10 still applies to all interfaces, and that's exactly what we're seeing. So this default IS-IS behavior does not allow for the higher speed path to be chosen dynamically. We can change this behavior by setting the reference bandwidth command under IS-IS. This will allow IS-IS to find the best path through the network automatically, preferring the path with the lowest metric, just like OSPF does. So our show route still shows the link through router 2 to be the best path to get to router 4. Our trace will probably do the same thing. If we trace to the 4 network, it's going through router 2. And to the 1 network from router 4, we're going through router 3. So you can see we got asynchronous routing going on between these devices, router 1 and router 4. Router 1 chooses the top path, which makes no sense because that's the 1 gig path, and router 4 uses the lower path to get to router 1's loopback, which does make sense because that's the 10 gig connection. So let's go ahead and set the reference bandwidth so that we can have some consistency throughout our network. We'll do set protocols IS-IS, reference bandwidth 100G, that's for 100 gig. We'll do this for all 4 routers. Set protocols IS-IS, reference bandwidth 100G. Let's commit that on R2. Move to router 3. Set protocols IS-IS, reference bandwidth 100G, it's for 100 gig. And the last router, router 4, set protocols IS-IS, reference bandwidth 100 gig. So let's go back to router 1 and 4 and see if there's any changes made to the interface metrics. On R1, we do a show IS-IS interface. We see the metric applied to our LT120.12 interface is 100, whereas the metric for the LT120.13 interface is 10. So we'll explain that in 1 second. Let's do a show route protocol IS-IS. And now we can start to see some different metric values being applied to routes throughout the network. We're seeing 63, we're seeing 83, we're seeing a metric of 20 to reach the 4 network. Before router 1 was going through router 2, now we can see that it's choosing router 3. So it appears as though our reference bandwidth statement has had some change so far to the way router 1 is going to reach router 4's loopback. Looks like our trace, we're now going through router 3 as the preferred path. And let's go ahead and explain to you very quickly how the metric or the cost value is calculated. So the cost is our metric equals the reference bandwidth divided by the bandwidth of the interface. So very quickly, we see that X equals, if we're trying to solve for cost equaling X, the reference bandwidth that we set was 100 gig. The bandwidth of the interface is set to, for the case of R1 to R2, that bandwidth interface is 1 gig. So 100 gig divided by 1 gig, X equals 100. So that's why we are getting 100 as our metric for the link from router 1 to router 2. So the metric for the link from router 1 to router 3, let's go ahead and do this again. Cost, our X equals 100 gig, which is our reference bandwidth that we set, divided by the bandwidth of the interface, which, if we go back on R1, if we do a show configuration interfaces LT120.13, the bandwidth we set to 10 gig. So we plug that into our calculation. So 100 gig divided by 10 gig, and X is going to equal 10. So that's how our metric values are being calculated. And that explains why our total to reach R4's loopback from R1 is a metric of 20. Because what we're seeing is between R1 to R3 a metric of 10, and R3 to R4 a metric of 10. But why is our directly connected interface to router 2 showing the correct metric in our show IS-IS interface? Let's go back to that. If we do a show IS-IS interface, we're seeing a metric of 100. But when we look at the routing table for router 2's loopback, we're seeing something different. Instead, it's giving us a value of 63. We see the metric value of 63. And the reason for this behavior is because by default, the IS-IS metric cannot be anything higher than 63 on an interface. So that brings us to our second topic of this video, which is wide metrics. So we have to enable wide metrics to get this value to change to its correct value. So we see the similar behavior on R4. If we do a show IS-IS interface, let's explain our metrics real quick. From 4 to 2, which is our 1 gig connection, is 100. That makes sense because the cost equals reference bandwidth divided by interface bandwidth. So 100 gig divided by 1 gig gives us 100. And then the link from router 4 to router 3 is a metric of 10, which is right because we have the reference bandwidth of 100 gig divided by the interface speed, which is 10 gig. So 100 divided by 10 is 10. If we do a show route protocol IS-IS, to get to router 1, we're seeing a metric of 20. Through router 3 is the next hop, so that's correct. We're going through router 3, which is the faster link, but we're still seeing the metric of 63 to reach router 2's loopback. And that's because the link between router 4 and router 2 cannot have a metric higher than 63, according to the default behavior of IS-IS. We're seeing a metric of 83 for the link to get to the 12 network. So how is that, you might ask yourself? Well, let's just follow the path. To the 12 network, we're going through the 34 network. So let's first find where the 12 network is, which is right here between R1 and R2. So the 34 network, we have a metric of 10. The 13 network, we have a metric of 10. And between R1 and R2, that metric is 100, but by default, without wide metrics being enabled, this interface is coming up with the metric of 63. So 63 plus 10 is 83. So what we should see when we is that when we change to wide metrics according to our reference bandwidth calculation, like I was telling you earlier, the links on R1 and R4 to router 2 should now show a metric of 100. And I must also point out that as we go ahead and implement the wide metrics, it is done under each level, and let's go ahead and do that. We'll show you that on R1 first. Set protocols IS-IS level 1 wide metrics only, and then we're also going to do it for level 2. So we'll do level 1 and level 2 wide metrics only. Why are we doing this under both levels? Well, that's what router 1 is. It's an L1, L2 router. So we're not going to change any of the default behavior of IS-IS. If you're running just a level 2 network, then you would just apply this under level 2. Same thing with level 1, but this is an L1, L2 network. We're not changing any of the defaults. So let's go ahead and move to router 2. We'll do set protocols IS-IS level 1 wide metrics only, and then we'll also apply this to level 2. So that's how you apply wide metrics under both level 1 and level 2 if you have the default IS-IS router type, which is L1, L2. On R3, set protocols IS-IS level 1 wide metrics only. Then we will also apply this to level 2. Last thing to do is get router 4 configured. Set protocols IS-IS level 1 wide metrics only. Do the same thing for level 2. So that's it. Let's give IS-IS a couple seconds to converge. And once we go back to router 1, look at the routing table, we should see the correct metric value of 100 coming up for the link between R1 and R2. Show route protocol IS-IS, and bingo, there it is. So we see the metric value of 100. That is again being calculated by the reference bandwidth of 100 gig, which we set, divided by the interface bandwidth, which is 1 gig. So 100 divided by 1 is 100. Let's go to router 4. Show route protocol IS-IS. We have the same outcome. You see the link to router 2 showing a metric of 100. So the metric in our routing tables and within IS-IS are no longer limited to 63 per interface, which is the default for IS-IS. That's the highest you can go. So we're now reporting the correct metric per interface. So it's very important to remember that if you want to set a metric higher than 63 on a particular interface within IS-IS, then you need to set wide metrics in your configuration. If not, then you will not have the outcome that you are hoping or looking for. So the last thing that we're going to do is set up the metric manually without letting IS-IS calculate it for us with the reference bandwidth formula. So right now, let's just do a trace. We can see that to get to the one network from router 4, we're going through router 3. Should see the same thing on R1. To get to the 4 network from router 1, we're going through router 3 as well. So let's say we want to use the path from R1 to R2 and R2 to R4 to be preferred. So the higher or the upper path through router 2. So what we can do is we can set a metric higher on one of the links so that 200 is the preferred metric. Remember, the lower metric is more preferred, just like OSPF. So what we'll do in this example, we're going to set the metric to 500 on the link between R3 and R4, and we're going to see what's going to happen. So on R3, let's go ahead and do this first. We'll do set protocols IS-IS interface LT120.34. That's the link between R3 and R4. And when we apply the metric values, so I'll do level 1 metric. We'll set this to 500. We also have to set it for level 2 because this is an L1, L2 router. So level 1 and level 2 metric of 500 set on router 3. Let's go ahead and do the same thing on router 4. So we'll do set protocols IS-IS interface LT120.43 level 1 metric 500. Then we'll go back and do level 2 as well. Let's commit this on R4. We'll quit and we'll see if this works. Let's do a show route protocol IS-IS on R1. And to reach the 4 network, we are now seeing the path through router 2, which is the next hop of the 12 network, with a metric of 200. Before, to reach the 4 network, we had a metric of 20 through router 3. Let's verify router 4. Show route. Let's just do this. Show route protocol IS-IS. To get to the 1 network, we're seeing the metric of 200, and that's exactly what we said was going to happen. Before, to get to the 1 network, we saw a metric of 20 through router 3. Now we're seeing a metric of 200 being the best path, or the best metric through router 2. And that's because what we now have to reach router 1's loopback is from router 1 to router 2 is a metric of 100, and router 2 to router 4 is a metric of 100. So that beats 200 beats the lower path, which R1 to R3 is 100, and the link between R3 and R4 is 500. So this is actually 600 if we were to take the lower path, which is not preferred. Lower metric is preferred within IS-IS to reach the destination. Let's go ahead and trace R1 to the 4 network, sourcing it from our 1 network. We're seeing the route through router 2, which is exactly what we want. And on R4, if we trace, we should see the same thing going through router 2. So we see 24.2 in the next hop. That's exactly what we want. So the routing tables and traces prove that the R1 to R2, R2 to R4 path is now preferred. Now, you can set the metric different on both sides, like on R3 and on R4, that interface on both of those routers. You can set those different, but what you'll end up with is asynchronous routing. So it's best to set the metric the same on both ends of the link. Let's do one last thing. We'll show you how this metric is applied. If we go to router 3, we'll do a show IS-IS interface. You can see the metric for the connection, the logical tunnel to router 4, which is 34. We see that metric of 500. And on R4 we should see the same thing. Show IS-IS interface. We have a metric of 500 going to router 3, or the link to router 3. So I just want you to remember that if you're going to use the reference bandwidth throughout your network, to have IS-IS automatically figure the best path, make sure that you turn on wide metrics. If you do not, then you are limited to having an interface metric of 63 as your highest metric value, which, as we saw earlier, when we set our reference bandwidth of 100 gig with an interface speed of 1 gig, the actual metric should have been 100, but it was showing up as 63 when we did not have wide metrics turned on. So that's it. That's the Juniper IS-IS Lab 4. We looked at metrics, we looked at wide metrics, we looked at the reference bandwidth, how that's calculated. Let me just show you what we configured. If we do a show configuration on R1, we turned on reference bandwidth to 100 gig under the IS-IS protocol. We also turned on wide metrics under the IS-IS protocol. We had to do that for both level 1 and 2 since this is an L1, L2 router. And then we showed you on R4 and R3 how we can manipulate the metric manually so that the reference bandwidth did not calculate the best path. We actually manually set the best path through the network. And we did that under Edit Protocols IS-IS interface that we wanted to, and then we set the level, both level 1 and 2, a metric value manually. So thanks for watching, and I hope to see you in the next video.